Section 11.6 is the next to the last rules we need to learn the derivatives of products and quotients, and then there's only one more rule. So in this section, we're going to start with products and then do quotients. So first we're going to figure out how we're going to tell if we need the product rule to do the differentiation. Then we're going to learn the product rule and apply it, and then the quotient rule, and then we'll be using them together. So when you have two functions that are multiplied together, like these two examples, you really have two choices. You can either multiply everything together, double distribute, and then use the rules you already know, or use the new rule we're going to learn in this video called the product rule. So for these two functions, you have those two options. For the next two example functions, the only option is the product rule. So it's kind of hard to demonstrate why you need to have it when we haven't yet learned the exponential and logarithmic functions, but know that that's coming. So these first two examples, I'm going to look at the first one and say, well, I have y equals the square root of x plus 3 times s squared minus 5x. And we can distribute, and we're going to first rewrite the square root of x as x to the 1/2, because in calculus, we never want radicals. We always want the fraction exponents. So when we do the first distribute, you need to add the exponents. So you're going to get x to the 5/2, then add the exponents and get negative 5x to the 3/2, then plus 3x squared minus 15x. So now we see that what we have, we already know all the rules for doing these derivatives. So y prime is going to be, use the power rule, 5/2 x to the 3/2, then minus 5 times, use the power rule, 3/2 x to the 1/2, plus 6x minus 15. And then we should just beautify this a little by combining the 5 and the 3/2. So we'll have 5/2 x to the 3/2 minus 15/2 x to the 1/2 plus 6x minus 15. So this is our derivative. And later in the lesson, we're going to do the derivative of this function using the product rule and see that they come out exactly the same. So that's a big point, that each function has one and only one derivative. And if you do it two different ways, and there often will be two different ways, you can't get different answers. Each function has one derivative. Okay, so I want us to discover the product rule and see how it has to work. So let's first start with these two functions u and v, and let's multiply them together. And that's going to give us 35x to the 5th. And then we know how to do the derivative of this quantity using our power rule. It's going to be 35 times 5x to the 4th. So that's going to be 175x to the 4th. So we know that has to be the derivative of the product of these two functions. Well, obviously it's not the product of the derivative. So let's look at that some more. So I'm going to write the u function here is 5x squared, and the v function over here, and give yourself lots of space because sometimes these functions are going to get long and complicated. So then I'm going to do the derivative of the u function using the power rule and the constant multiple rule. So I'll have 10x, and then the derivative of the v function is going to be 21x squared using the constant multiple rule and the power rule. Okay, so now I want us to do this multiplication that comes from doing the diagonal multiplication of u times v prime, and see that we're going to get 105x to the fourth. And then do the diagonal multiplication the other way, and see that you're going to get 70x to the fourth. And then look at what you know your answer has to be, and see that you can get it by adding these two quantities together. So this is how the product rule works. This quantity over here is uv prime, the 105x to the fourth. Then the 70x to the fourth is vu prime, and then there's a plus. So the derivative of the product of u and v is, don't change the second function, multiply it by the derivative of the first. Then don't change the first function and multiply it by the derivative of the second. So if you look at the way it's written out in your book, you can see that we have the same two quantities. We just have them in the opposite order, and adding order doesn't matter. But I'm getting us ready for the quotient rule so that you can do the quotient rule and the product rule the same way rather than having to learn two different strategies. So the order is a little bit different than in your book, but this is how I'm always going to do it. So if you learned it a different way, that's fine, and I will figure out your way as long as it's clear. Okay, so the product rule. So we're going to write our version of it. It says, if my function looks like two functions multiplied together, then I do the second function times the derivative of the first plus the first function times the derivative of the second. Okay, so let's look how we would do this with our first example. I'm going to do a rewrite step first of always rewrite radicals as fraction exponents. So now my u function is x to the 1/2 plus 3. And my v function is x squared minus 5x. Then u prime, use the power rule, is 1/2 x to the negative 1/2. And my v prime, using the power rule, is 2x minus 5. Okay, then I'm going to do my diagonal multiplication, and I'm just going to write it out first because it's going to take some work. It's going to be x to the 1/2 plus 3 in parentheses times 2x minus 5 in parentheses. And then when I do the diagonal multiplication the other way, I'm going to have 1/2 x to the negative 1/2 times x squared minus 5x, because the order of the multiplying doesn't matter. And we're going to label this y prime. So as long as you have one function and the other one's derivative, and then switch which one has the derivative and which one's unchanged, your product rule is going to work. Okay, now we need to do some beautification here. This is kind of messy looking to me. So we're going to distribute and get 1/2 x to the 3/2, add the exponents, minus 5/2 x to the 1/2. And now I'm going to need to double distribute, plus 2x to the 3/2 minus 5x to the 1/2 plus 6x minus 15. Okay, so now we have some like terms, so let's gather them up. Here's some x to the 3/2 and some more x to the 3/2. So that's going to be 5/2 x to the 3/2. And then I have negative 5/2 x to the 1/2 and minus 5x to the 1/2. So combine the coefficients and don't change the exponent part. So this is going to be minus 15/2 x to the 1/2 and then plus 6x minus 15. And let's go back and look at what we did earlier. and it's exactly the same. So whether you multiply first and then do your derivative, or use the product rule, you're going to get the same result. Okay, so let's do another practice problem together. I'm going to rewrite my f of x with a fraction exponent. So I have x squared minus 3 times x to the 1/2 plus 5. Okay, so I'm going to use the product rule. And I'm going to have my u function be the first function, x squared minus 3. Then I'm going to have my v function be the second function, x to the 1/2 plus 5. Okay, now I'm going to do each function's derivative. U prime is 2x. V prime is 1/2 x to the negative 1/2. Then I'm going to write out my multiplications. I'm going to have 1/2 x to the negative 1/2 times x squared minus 3. And 2x times x to the 1/2 plus 5. And I need to add those together. And that's going to give me f prime of x. Okay, so now let's do our algebra beautification. Distribute. Add the exponents. I'm going to get 2x to the 3/2 plus 10x plus 1/2 x to the 3/2 minus 3/2 x to the negative 1/2. So let's look for any like terms. I see some x to the 3/2. So combine like terms by combining their coefficients and don't change the part with the x. So I'll have 5/2 x to the 3/2. Then I have plus 10x. And then I require that you write your answer with no negative exponents. So no negative exponents in answers. So this is your final full credit answer. Okay, so that's the end of the product rule. I'm going to go ahead and stop the video here and then make a separate one for the quotient rule.